Hello, beautiful people, and welcome. In this video, we are solving quadratics. Now, this is a review video, so we're going to go through all of the methods of solving quadratics. Factoring, taking the square root, completing the square, using the quadratic formula. As always, I am human. If I make a mistake, please let me know where the mistake occurs so that way I may learn from it and you can learn from my mistakes as well. So the first way we were instructed to solve quadratics is by factoring. So when you have factoring, you're going to set the given equation, the given quadratic, equal to 0. If it is not already an equation, create an equation. Sometimes they will already have 0 or they will have something on the other side, but you want it equal to 0. After this, you're going to look at what type of quadratic you have. Is your A value 1 or is your A value not 1? So looking, if you're in my class, we have this graphic organizer here. So if A is 1, and in this case it is, there is no number next to our leading coefficient here, our leading term. So our leading coefficient is 1, excuse me. So then we have the guess and check method. We're going to look for a GCF if there is one. And then we're going to make sure to include the front side of C and list the factors of C. So we want no GCF here because we only have one. We want two numbers that multiply to get us 15 and add to give us 8. Now we're going to create our factor bubbles here. And again, this is all set equal to 0. And so two numbers that are multiplying to 15. Well, 15, I have 15 times 1. I'll do a little mini thinking bubble here. 15 times 1 is 15, but 15 plus 1 is 16. I need an 8, so I need smaller numbers. I'm thinking 5 and 3. If I have 5 plus 3, that does give me 8. So 15 and 1 does not work. However, 5 positive and 3 positive work. Now, our variable is k, so I'm going to bring down k. And the reason 5 is positive and 3 is positive because positive 5 times a positive 3 gives us a positive 15, which is what we need. And also positive 5 plus positive 3 is equal to a positive 8, which we have here. Once we set our factors equal to 0, we separate them out. Every single factor, every single bubble is now separated and set equal to 0 separately. We're going to then continue to solve for our variable. And once you have your variables alone and solved for, you are done. Now you can leave your answers like this in my class, or you can combine the answers and say k is equal to -5, comma, -3. This is not a coordinate point. This is just listing the values of k. Let's do the other one. Another one saying 7m squared minus m minus 6. Step number 1 is always GCF. 7, 1, and 6 do not have anything in common. Step number 2 is to identify if we have a is 1, a is not 1. So let's see here. In this case, my a value is 7. So I'm going to look at my cheat sheet here off to the side and use this slip and divide method that we were taught in class. Take your leading coefficient, multiply it by your constant. So I have m squared minus m, and then 7 times 6 is 42. Keep the minus. Now that I have a quadratic with a leading coefficient of 1, we're going to factor using the guess and check method. So we want two numbers that multiply to a -42, but when I add them, give me a -1. And I'm thinking 7 and 6. 7 times 6 is 42, but I need a negative. But when I add them, I need one more negative than the other one. So it's going to be -7 and a +6. My variable, my letter is m. And we are not done. The reason we are not done is because we here multiplied by our original leading coefficient of 7. Therefore, in this step, we have to undo that original multiplication by dividing by this 7. So I'm going to divide both numbers by 7. Simplify your fractions if you can. So 7 divided by 7 is 1. M plus 6 divided by 7 cannot be simplified, so I'm going to leave it as a fraction in this step. Now, any fractions that you are left with, the denominator is going to be brought out in that one specific bubble, and that's going to be your new coefficient for that factors, for that parenthesis bubble. So I have here m minus 1, and I have 7m plus 6, still equal to 0. Now that I'm done factoring, I will separate all of my bubbles out, just like we did here, and set each one equal to 0. Now, once you've set it equal to 0, you're going to solve, get your variable by itself. So m is equal to a positive 1, minus 6 on this side, 7m is equal to negative 6. I'm going to divide by 7, so m is equal to negative 6 sevenths. And it's okay that it's a fraction. Just make sure that if you can simplify your fraction to do so. Next method we have is taking the square root. First step in taking the square root is you want the squared, anything that's squared, to be by itself. So everything else needs to be removed. This is going back to pre-algebra, algebra, integrated math 1, whichever class that you took. Remove the addition subtraction first from the side that has your variable squared. So in this case, I have a minus 9. So I'm left with 3 times a squared. And then 117 minus 9, that's equal to 108. I'm now going to divide by 3 both sides to get rid of 3 on my left-hand side. And 108 divided by 3 is 36. Now that you are here and a squared is by itself, we're going to undo the square. The opposite of addition is subtraction. The opposite of multiplication is division. So the opposite of an exponent of 2 is taking the square root. So a square root looks like this. And there is a secret 2 here. Usually you do not see this, but I'm going to write it just to show you. This number 2 that I just wrote down, that is called the index. Now the index just tells you how many numbers that are the same that you need to multiply to get in here. So this number 2 and this number 2, they cancel out, they undo each other, and so you're just left with a. Now because we took a square root on my left-hand side, we must 1,000 bajillion %. We must do it also on the right-hand side. However, on the right-hand side here, we're going to add a plus or a minus because I know that I can have 6 times 6 to equal 36, and I can have a negative 6 times a negative 6 to equal 36. Anytime you are solving an equation and you are taking a square root, there has to be a plus and a minus with that square root. So what you're actually going to write your answer as is a plus minus square root of 36. Let's do that, which is equal to plus or minus 6. Now this here is your answer, are your answers, since you have plus a 6, a positive 6, and a negative 6 for the solutions. Let's try to do this one more time. Again, get your variable squared, whatever, if it's a bubble, get that bubble squared, whatever squared, you want it by itself. So I'm going to add 9 to both sides. I just realized it's the same step on both examples. It doesn't matter. Okay, I'm going to bring down 100 times a squared. Negative 5 plus 9 is 4. Now I'm going to divide by 100. Divide by 100. A squared is equal to 4 divided by 100. Okay, here's the thing, you guys. This one's a little bit different, but don't worry, it's going to be okay. Same step, which is the square root. Again, this is a secret 2 here, and then on this side you have a plus or a minus. My squared and square root, they undo each other, so I'm left with just a. Now on this side, notice I have perfect squares. I have 4 and I have 100. So we're going to take advantage of the fact that those are perfect squares, and I'm going to split up my fraction. I'm going to take the square root of 4 and I'm going to take the square root of 100 separately. So we're going to put a square root on top, we're going to put a square root on the bottom. Now that I have separated my square roots, and you are allowed to do that only with multiplication and division. So you are allowed to separate this out. So then what is the square root of 4? Square root of 4, oops, there should be an equals, is 2. What is the square root of 100? That is 10. Now I'm going to bring it up here. I'm going to separate these two. I'm going to rewrite it. So I have a equals plus or minus 2 divided by 10. I almost said 100. It is 10. 2 divided by 10. Now notice that 2 divided by 10 is not simplified, because 2 can go into 2. 2 can also go into 10. So I'm going to simplify this fraction. So I have 1/5 as my final answer solution. With that plus and minus, make sure you have that plus and minus. All right, next step we have is called the completing the square. Now, completing the square works if factoring doesn't work. We like to save completing the square for things that are just not pretty. So when you are completing the square, step number 1 is setting the equation equal, to 0. Sometimes they'll be set equal to something else. As long as you have an equation, it's fine, but it has to be an equation. Step number 1 is take your constant, the number, whatever this number is. You're going to undo it, or you're going to move it over to the other side. So I have a negative 78. I'm going to add 78 to both sides. So I have b squared plus 18b, nothing here, and then here I have 78. Now, this is going to be your first check. I'll wait a few seconds to explain that, but I'll wait a few seconds. Sorry about that. Okay, take this middle term, and you're going to the number. You're going to take that number, in this case 18. You're going to divide that number by 2, and you're going to square it. Now, 18 divided by 2 is 9. And 9 squared is equal to 81. And I'm going to use a third color here to show you that now it's equal to 81. Take that 81, and you're going to add that 81 to both sides. So I'm going to rewrite this here. I have b squared plus 18b plus 81 is now equal to 78 plus 81, which is 159. Remember that 18 divided by 2 that we did? Remember this 9? It is our middle term divided by 2. So that 9 is one of your, or both, factors for our quadratic. So when we have our factoring bubbles, you're going to take that value of 9, and that's going to be your two numbers here, positive 9, positive 9. And the reason it's positive is because 18 here was positive. Now, what is our variable? Our variable was b and b. Now, on my on my right-hand side here, I still have this 159. Notice that I have b plus 9 and b plus 9. You're going to write that as a perfect square, because it is. So you're going to write, let's take this up a little higher so you guys can see it, so I don't run into my other example for you. So I have b plus 9 squared is equal to 159. Now, remember that check I said? There's a check that you have to do, and this is it. If this number is negative, your answer is no solution. So this number here must be positive. So if you have a negative number in this step here, you have no solution. And this is why. Remember how we have now a squared? We're going to undo it. Our objective is to solve for our variable b. So I'm going to take the square root, remember plus or minus, of both sides. And so I have b, remember there's a secret 2 here, so that goes away. I have b plus 9 is equal to the square root, plus or minus always, of 159. Now, I do not believe 159 is a pretty number, 159 square rooted, and it is not. And that's okay. It doesn't have to be. We can see if it simplifies, but I don't believe anything goes into 159. Thinking maybe 9. 9 doesn't go into it. 159 maybe. And I'm checking here on a calculator to see if there's any perfect squares that go into 159, and there are not. So we can just keep it as 159. Again, that's okay to keep it this way. Notice there's a plus and a minus, so I'm going to separate this out into 2. I have b plus 9 is equal to a positive square root of 159, and I have b plus 9 is equal to a negative square root of 159. Again, don't let that square root give you any trouble. It's a number, it's just not a pretty number. So we're going to subtract 9. Now, keep in mind we have to subtract 9 from the square root. So we cannot go inside the square root, we have to go outside the square root. So I'm going to say this, b is here, and I have a negative 9 plus the square root of 159, and I have, didn't mean to move that, b, let's give it a dotted line, minus 9 minus square root of 159. We typically put like just singular numbers outside in front of the square root, so we don't think that it belongs inside. So what are our answers? B is now equal to negative 9 plus or minus the square root of 159. And that's your answer. Again, it doesn't have to be a pretty answer. It just has to work. All right, let's try it again. Now, notice the difference between this example 1 here and then this example 2 here. Notice in this example, b is just b squared. It doesn't have a leading coefficient. Here, there's a 6, and there is a leading coefficient. So if there is a leading coefficient, you must divide out. You have to have a leading coefficient of 1. So because I have 6 here, I'm going to divide all of my terms, not just one, every single number by my leading coefficient. So 6 divided by 6 is 1, so I have x squared, minus 12 divided by 6 is 2, 96 divided by 6 is 16, equal to a negative 1. Now, notice this is a negative 1. That's okay here. We need to know if it's going to be a square root is equal to a negative number. Right now, we're not there yet. We're going to check later. So now that we have a leading coefficient of 1, we're going to remove this constant by adding 16 to both sides. So I have x squared minus 2x, and that's equal to, definitely not 16 because I have a negative 1 plus 16. So a negative 1 plus 16, let's keep it in red. Negative 1 plus 16 is a positive 15. And that's equals, again, leave some space here. You're now going to take that middle term. You're going to take that number, divide by 2, and square it. It's always divided by 2. It doesn't matter what this number on top is. It's always divided. It's always squared by 2. So negative 2 divided by 2 is a negative 1. Negative 1 squared is a positive 1. So you're taking that positive 1 and you're going to add it to both sides. I'm going to continue this problem here on this side. So I am left with x squared minus 2x plus 1 equal to 15 plus 1. So this plus 1 came from b divided by 2 squared. So x squared minus 2x plus 1 is equal to positive 16. So now this is a positive number, so we can continue. Again, factoring bubbles. Now that we have a factoring bubble, what you're going to do is, remember this one here, the b divided by 2 number, which was negative 1. You're going to take that negative 1, and those are going to be your factors. So I have x minus 1, and that's equal to positive 16. Now we have x minus 1 squared, that's equal to 16. We can take the square root of it. Again, make plus or minus always. Again, there's a secret 2 here, so the 2's, they go away. So I have x minus 1 is equal to plus or minus the square root of 16. But what is the square root of 16? The square root of 16 is 4. So x minus 1 is equal to plus or minus 4. We're going to separate out into 2 separate equations, just like we did in the previous example. X minus 1 is equal to a positive 4. X minus 1 is equal to a negative 4. We're going to solve this for x. So I have plus 1 plus 1. X is equal to 5. And here I have plus 1 plus 1. X is equal to a negative 3. All right, beautiful people, this wraps up part 1 of your review. In the following video, we will be talking about quadratics and discriminants. Thank you so much for watching. Take care. Bye.